Oh. Okay, let's continue our class. Okay, today is where we are. Okay, this one. We have two very important topics. Topic 10, which is static analysis, and topic 11, dynamic analysis. Okay, there are two different philosophies, two different ways to analyze. Okay, to analyze a malicious software. So I would like to say something more about these two different analysis method. Okay, left hand side. Okay, the first one, static analysis. Okay, the right hand side, dynamic analysis. Okay, in Mandarin that is 静态分析哈，静态分析哈。The right hand side that is 动态分析哈，动态分析。And the most important of things that two different method is that while you do static analysis, okay, first you have to obtain the execution file. As we mentioned in the last week, okay, that is the PE file or the ELF file in Linux-based or Unix-based machine. So that's the execution file you get. So you have a binary file obtained from, maybe you got it from your spam mail attachment, or you get it from the internet, or some malicious people, okay, they send you this file. Okay, that is the file. And at the right hand side, of course, for dynamic analysis, you still need to obtain the execution file. It's the same, okay? But the second step is a little bit different, okay? For static analysis, the most important thing is that you do not, okay? So you do not execute the file. For all of the static analysis methods, you don't want to execute the file, because this file is very, for example, malicious or is harmful for your system. So you do not want to execute the things. So you simply just get this file. You have a binary file, first bit, second bit to the last bit. You use different method to analyze what is inside in this file from the very first bit to the very last bit. Okay, so you do not execute. But for dynamic analysis methods, okay, you want to execute the file. So, however, basically, you don't want to do something bad to your system, right? So basically, you need to set up what we call sandbox. It is sandbox, so you can safely, okay, execute your malicious file in that sandbox. That sandbox is separated to your, for example, your operating system, so it cannot do anything harmful to your system. Okay, and usually, currently, in current dynamic analysis method, usually we use a virtual machine. Okay, I'm not sure if you have you ever heard about any virtual machine system. For example, virtual box, which is a product from Oracle, okay, or VMware. Okay, it's a company to allow you to create a virtual machine inside your current physical machine. So that, but they are separated. Okay, so you can safely execute any malicious code, any malicious file inside your virtual machines. Okay, so there, of course, there are a lot of different companies who create who have virtual machines. Okay, so that and after you so the different is running. So for static analysis, since you only have those bytes or bit, so basically, okay, you have to understand the structure of this PE file or ELF file, right? Okay, just as what we did in the last week. Okay, there are several different headers. Okay, there are several different headers, payloads inside the PE file, so that you have to extract, okay, certain important parts from those headers, those PE headers, those contents. Okay, try to obtain valuable, useful information from the file. So I have to extract useful, valuable information from that here, because you don't want to execute it. So you can you can only simply just extract useful information, and we will talk about what kind of information you can extract from a PE file. Okay, in the next 2 hours. Okay, so that is. However, at the right hand side, because you want to execute the malicious file for the dynamic analysis, so you have to build up a lot of monitors. And usually, okay, we call it profiler, which means you need to set up a monitor, okay, to monitor how this program is executed by your operating system. What kind of files, for example, okay, for example, what kind of files that the malicious file would like to read or write, okay? What kind of Windows API call, which means library. What kind of library that the malicious program would like to invoke? Invoke 中文就是应该说拿执行的哈。Would like to invoke, because Windows provide tons of libraries, okay? For example, to control your monitor, to control your keyboard, to control your mouse, to create a Windows UI interface, to control your hardwares, something like that. To do encryption, to do decryption. There are a lot of different libraries provided by the Windows through Windows API. So the malicious program will maybe they would like to use such kind of library. So we'd like to monitor what kind of libraries has been used by the malicious software. Okay, register, registry, TRY. Okay, registry. Windows has a lot of settings which is stored in Windows registry. Okay, we will show you that later. So you may want to know what kind of registry, what registry has been modified or accessed by the malicious software. Okay, networks. You would like to know how many socket has been created by this program, and which IP address has been contacted by the malicious software. What kind of what packet has been transmitted from the malware to maybe attackers outside in the internet. Okay, so there are a lot of different subject that you can monitor, okay, to describe the behavior of this malicious software. So basically, dynamic analysis is trying to, we use the word profile, okay, profile this program, okay, to build a lot of monitors to monitor different subjects, so that we can understand what the malware want to do, or do anything harm to our system. Okay, that is the most important part of dynamic analysis. However, when you collect a lot of different information from different monitors, then the next thing you have to do is to trying to model this behavior. Okay, this behavior is quite complex. Okay, there are several different subjects. For example, files, library calls, register, and network. Okay, there are different monitors. So you have to combine them as a whole to do a model and trying to describe, okay, to profile this malicious software. And of course, you can run a benign software, or what we call a normal software, okay, and you do exactly the same thing to profile it. Okay, so if we can create a model that can help us, okay, to differentiate the behavior of malicious software and the behavior of benign software, then that classifier will be very useful, right? Because you collect a lot of different informations from different monitors, okay, and you give me and there is a new software sample, and you simply just monitor it for a period of time. You collect those information, and you feed those information to your model, to a classifier, and your classifier can make a judgment, okay, to see if it is a malicious software or it is a benign software. That will be very useful for you to do detection, malware, malicious software detection, right? So that is the basic idea of dynamic analysis. And at the left-hand side, of course, you can use those extracted information from the execution files, right? And you can collect a lot of malicious software, and you can also collect another set of benign software, and you extract those some information from the executable file, and you can also create a model, right? This model will based on those information you extracted, right? And you create a classifier, and based on those informations you extracted from the PE files, you can differentiate benign software and malicious software. So basically, you create a model, right? Those model has a lot of different features extracted from the PE files, and this model can answer a question: is this a benign software or it is a malicious software? Okay, so basically, static analysis and dynamic analysis, they both do the same thing. They would like to know which one is malicious software or which one is benign software. But basically, their information is from different place. Okay, dynamic analysis, they need a monitor to monitor the runtime. Okay, runtime behavior. They collect the runtime behavior from different aspects, and they use those information as the features to fit in the model you built. Okay, and then they do the classifier. However, for the static analysis, they don't run the execution file. Okay, they simply just extract some information from the PE files, and they do a classifier. Okay, so that is the difference between static analysis and dynamic analysis. And of course, there are some pros and cons for static analysis and dynamic analysis. Okay, for example, basically, pros. The pros is that the pros of static analysis is basically that you don't need to run the file. So it is more easier for you to analyze, because you can obtain several thousands or tens of thousands of malicious files and just put them in your disk, and you can analyze them one by one, and the analysis should be very quick, right? Because you simply just extract the useful information from those files. Okay, you don't need to run, so that's more quick. However, the cons is that currently a lot of malwares, okay, they simply just put some very naive, trivial, very simple behavior inside that PE files. And further, if they has been executed, okay, in your system, they will further download more complex code or script from the internet, from attackers, and they download the script or complex code from the hackers, and then they execute those complex code later. So basically, if you only analyze the PE files, which might be not that useful, because the important part, okay, of this malicious program is not in a PE file. They will further download those complex code, those harmful code from the internet. So basically, they do not content runtime behavior. Okay, usually they can download from internet. Since you do not execute this file, so you cannot obtain the download file from the internet. So you don't know what the malicious program will do after they download the malicious script or code from the internet. Okay? At the right hand side, okay, pros. Runtime. Since you execute the execution file, okay, because you use dynamic analysis, so you can observe those runtime behavior. No matter they download the file from the internet, they contact the attackers by using some socket. Wait. No matter they download the file from the internet dynamically, or they execute some code, or they download something, and so on and so forth, those runtime behavior can be observed. Okay, can be observed. Right. So complex behavior can be observed. Of course, the cons is that you have to set up a sandbox, and you have to wait. It is not quite easy to set up such kind of sandbox, okay? Because every time you execute a malicious file, you have to destroy the sandbox, because you want a clean sandbox to do the next experiment. So every time you, for example, you have 10 malicious files to test, okay? You have to set up a sandbox for each of them, and every time you do the experiment, you have to destroy the sandbox to create a new one for the next sample. Okay, so that's not quite easy. The other thing is you have to wait, because after you execute your execution file, okay, malicious file in your sandbox, in your virtual machine, okay, you simply just double click this execution file in your sandbox windows, and then you have to wait. Basically, you don't know when the malicious program will do something harmful to your system. And you don't know when the malicious file will contact the remote attacker. So you have to wait. 1 minute is enough, or 2 minutes, or 3, or 5, or 10, or you have to wait for 1 day, which is unknown to you. So basically, it is a time-consuming process. Okay. Usually, for some research papers, they wait for only 5 minutes to observe the runtime behavior of a malicious software. If there's any behavior which is not happen within 5 minutes, then you cannot observe it because the observed time is only 5 minutes. So I have to decide how long you should observe malicious behavior in dynamic analysis method. Okay, so that is I think that is a basic difference between static analysis and dynamic analysis. Okay, let's go back to the topic 10. Okay, static analysis. Okay, we have talked about some concept last week, and let's continue. Okay, let's start from here. Okay, as we mentioned before, the files, they are simply just binary files. So you can use a hexadecimal way to print it. Okay, every byte, okay, of your PE file can be printed as this. Okay, so 4D is the first byte, 5A is the second byte. Okay, it is a hexadecimal system, so we need 2 hexadecimal digits to represent a byte. So that is the byte. Okay, so you have to do this. Okay, that is the first thing. Okay, the next topic is called hash. Python provides a lot of different hash libraries, so you can use them. Okay, so let's take a look at it. This one. Okay, take a look at this one. We use putty, okay, this execution file as our example through our class, right? So basically, I like to calculate the hash value of this putty32.exe file. So I read this file and I put this file in a hash function. Okay, hash function has a lot of different algorithms or different versions. Okay, the one I choose is MD5. It is a very important hash function. It is widely used by security research field. Okay, so I simply put all the files, okay, every byte, okay, in that hash function MD5, and here is the result of this putty32.exe file. It's MD5 value. Okay, MD5 is a little bit complex, so we'll now go through this algorithm. Okay, the only thing you have to know is that you can put every digitalized content to this MD5 function, and this function will output a value based on your input. So we input the putty32, every byte in this execution file to this MD5 function, and it output a value which is right here. This the representation is also hexadecimal, right? So it's like that. And you can also use any other hash function. For example, this is SHA-256. Okay, this is another hash function. Okay, and the result is right here. Okay, F2D2 blah blah blah. Okay, and basically this value can uniquely identify this file. Okay, because we have these hash functions, they are deterministic. 中文很难翻译哈。deterministic 的中文应该就翻译成，它已经是决定好的内容，所以你的应该说它的流程哈，就是 MD5 跟 SHA 它的都已经决定了，里面没有任何随机的部分，所以你输入进去之后，经过一连串的运算，输出的结果就是 deterministic， 就是一定的。好，它里面没有任何随机的结果。中文是这样翻译的。So every time you put putty32.exe to MD5, and the result should be 37 for F blah blah blah. Okay, it is deterministic. Okay, but when you change one bit in putty32.exe, the result of MD5 will be not 37 for blah 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 blah. So one single bit will change the result of the MD5. So basically, every time you put putty32.exe to this MD5 function, and the output will be the same, and you change one byte, even one bit, the result will be different. Okay, that is the idea of hash function. Okay, so that is it. Okay, there are several other concepts right here. Okay, in Putty's web page. Okay, in Putty's front page, you can see there are two different things. Okay, one is PGP value and the public key provided by Putty, the Putty website. Okay, so basically I would like to talk about something about digital signature. Okay, so let's go to our website. There's an entry called digital signature. Okay, we simply just take a look at the Wikipedia right here. Okay, here is an example of digital signature. So basically, we can see that we have two entities or two peers. One is called Alice, the other is called Bob. Okay, they would like to transfer a message from between each other. Okay, the message right here is "Hello, Bob." Okay, the light blue block, which is a message like to pass from Alice to Bob. Okay, and the Alice would like to make sure this message, okay, Bob and Alice would like to make sure the message is safely transferred from Alice to Bob and cannot be forged. Forged 就是伪造。So Alice would like to add a signature on this message. 就是 Alice 跟 Bob 想要做一个比较安全的通讯，他们不想要这个讯息被伪造，所以他们就想说，那我就签名吧，然后就跟现在的文件一样嘛，对不对？下面就签一个你的名字 ，OK？ So they would like to, Alice would like to add a signature, okay, on this document. So basically, the yellow block is sign. There is a method, there's a function called sign, okay? Alice need one important component at the right hand side, which is Alice's private key, which is a digitalized key, okay? Only accessible by Alice. Alice cannot share this her private key to any other else. So this is a private key, okay? A digitalized key, only accessible, only obtainable by Alice. Alice cannot share this key to any other else. So basically, there's a sign function, okay, which is made up by hash function, as we mentioned before, okay? So Hello Bob and Alice private key will create a digital signature, which is the yellow block, BE4595, this block, okay? And they will attach, Alice will attach this digital signature, okay, on the message, which is Hello Bob, and send the message and the digital signature to Bob through even an unsafe channel. Okay, the reason why they use MD5 and the Alice private key to create signature is because only Alice herself has this private key. Okay, so through a sign function and the Hello Bob, okay, they can create a unique digitalized value, which is the BE4595. That is the signature. Only Alice herself can create such signature by using Alice's private key. Without Alice's private key, no one else can create such kind of signature. Okay, so after this message and this key, this signature has been transferred from Alice to Bob, even through an unsafe channel. Okay, when Bob receives such kind of message and digital signature, okay, Bob can run a verify function. Okay, this verify function should input the message, of course, the message hello Bob, and also Bob can obtain Alice's public key, which is right here. Okay, Alice's public key. Sorry, that's Alice's public key. So this public key can be public accessible by anyone else. Okay, so Bob can easily obtain this Alice public key, maybe from a trusted peer or from maybe Alice's website. Okay, so only Alice public key can verify, okay, if this signature BE45 blah 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 is created by Alice private key. Only Alice private key can create such kind of signature, and this signature can be only verified by Alice's public key. Okay, so in this case, okay, let's go back to Putty's website. Okay, so I think it's right here. Okay, in Putty's website, you can see that. Okay, here we have Putty, right? Putty.exe right here. At the right hand side, you can see that Putty's website provide the signature right here. So you can simply just click it. Okay, right here. Okay, at the bottom of this page, okay, you can see putty.exe.gpg. Okay, 438 byte has been downloaded. Okay, and here you can see that is the signature. Okay, it includes signature of putty.exe and also include Putty's public key. So you can use the Putty's public key to verify this file, every byte, every bit of this file, putty.exe. They're exactly the same. Okay, they are verified by the signature. So, some serious website or serious program developer, they will provide the public key or the signature on their website, so you can verify them by yourself. So, I write some Python code. Okay, so you can simply just take a look at the following cell, which they verify Putty's signature and by using their public key. So you can simply just take a look at these things. Okay. The reason why we would like to teach you what is signature and how to verify them is because there are some, I say, serious programmers. After they create their own programs, their execution files, they also provide such kind of a signature and public key in their website. So you can easily verify if your download program is exactly the same as the program provided by those programmers. Okay, through this verification process, there's no way to create a forged or a malicious version of the software. There's no way, because you can verify if your download file is exactly the same as the file, the program provided by the programmers. Okay, so usually if you got a file, for example, from your friend, and your friend says, okay, this file is quite safe because it contains a signature provided by, for example, Microsoft. And you can simply just go to Microsoft website and use a tool provided by Microsoft to verify if this file is indeed provided by Microsoft, because it has Microsoft's signature as embedded in the PE file. So there is a section in PE file. Okay, it can include a signature. So basically, when we analyze tens of thousands or millions of exe file, the first thing we have to do is to verify if this file has been signed by a trusted programmer. For example, Microsoft, Adobe, right? For example, Trend Micro. For example, there are a lot of different big companies. Okay, they provide their signatures, their public keys, so that you can verify this file is indeed from those programmers, those big companies. So if those those signatures indeed exist, and then we usually trust them. So say, okay, that is not a malicious file, so we simply just save it. OK， 好，中文就是说了，那些那个大公司啊，或是一些有责任的那些 programmers 啊，他们都会在他们的网站提供 signature 跟 public key。所以然后在 PE file 里面有一个 section 有一个区段是专门让你放signature 的。所以当我们要分析什么成千上百万个 malware 的时候，或是sample 的时候，我们通常做的第一件事情就是先把它拿过来看一看里面有没有 signature。如果里面有 signature， 你就看它是哪一家，它上面会标明说这是 Microsoft 的，你就去 Microsoft 的网站去下载一个工具，或是去你自己像我这样写也可以哈，它就会去 verify 说这里面的每一个 bit 每一个 byte 是不是跟 Microsoft 当初 release 这个 file 的时候是一模一样的。如果完全一模一样的话，基本上我们应该是相信像 Microsoft、Adobe 啊、Trend Micro 那些大公司哈，它既然在上面已经签名了，而且签名可以认证说每个 bit 每个 byte 都没有被篡改过，那通常我们在分析恶意程式的时候，我们就会跳过这些程式，因为它是被 sign 过的，它是那个 programmer 当初写好被 sign 过，所以它基本上没有被篡改呀、修改的那些疑虑，所以在大量的资料分析里面，我们就会跳过这些 PE file， 好，减轻我们的负担嘛。因为等一下 PE file 要一个一个 byte 拆开看，那个是很耗时的，对不对？那如果我们可以简单的有一些简单的方法，像这个 signature 就跳过它，就跳过它了。好，那基本上会加速你的分析流程。Okay. So we have 10 more minutes, right? So I'd like to introduce a website which is called VirusTotal. So simply go to our website. VirusTotal, okay? And we can search. Okay, we simply just search load money. Load money is a malware's name. Okay, so we simply just click random one. Okay, that is good enough. Okay. As you know, we have a lot of different brands of antivirus software, right? Something like maybe Trend Micro, right? Kawasaki, okay? Norton, FireEye, McAfee, okay? Microsoft Defender, okay? There were a lot of different antiviruses. In total, there are around, I think, more than 70 or 80 antivirus engine, antivirus company. Okay, they have antivirus engine. Okay, so basically, when there is a new malware sample, okay, in the internet, okay, those companies will collect, okay, in any ways to collect this malware. For example, this malware is called load money. Okay, and load money. Okay, and here we can see that this execution file, okay, this execution file, it's SHA, it's SHA-256 value. Its hash value is C30A17CD blah 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 blah. Okay, so that we can use this hash function to uniquely identify. Okay, that is exactly PE file. Okay, when we talk about this C30A17, okay, every malware, let's talk about the same sample. Okay, because this sample has a unique hash value. Okay, so at the left hand side, okay, there are 71 different antivirus engine. Okay, so here we have 71 records right here. Okay, and we said 59 out of 71 antivirus engine, they believe, okay, this malware sample C30A1750 blah blah blah, this sample is a malicious file. So 59 out of 71, okay, they believe it is a malicious file. Okay, that is how you read this part. Okay, at the right hand side, okay, this file, its size, its PE file, its size is 684 kilobyte, and the very first time, okay, when this sample, this malware sample has been observed is 2020, okay, April 13, which is 11 months ago. Okay, so that is how. At the right hand side, it is a exe file. So it is a PE file. Okay, so that's how we read this. Okay, at here, okay, for example, let's take a look at Microsoft. Okay, among these 71 antivirus engine, okay, Microsoft label this malicious malware sample as PUA. P means possible, U means unwanted, A means application. So Microsoft labeled this malicious file as it is probably unwanted application, and it is a Win32. Win32 means it is executable on 32-bit Windows operating system. Okay, and it gives it a name. It's Presenoker. Okay, it's just a name. Okay, a researcher of Microsoft. Okay, after they do the dynamic analysis, after they do the static analysis, okay, they give this sample a name, which is this one. Okay, and as you can see, different antivirus engine, for example, Symantec 就是赛门铁克哈。Symantec, the researcher of Symantec, they give it a name called Load Money, LOADMONDY. Okay, a Load Money. And as you can see, there are a lot of different names. Okay, even this one. Okay, ESETNOD32, that is Norton, 就是诺顿，好，就是另外一个防毒软体。Its name is like a variant of Win32, Cryptic. It is also a name. Okay, so basically, different antivirus engine, the researchers of different antivirus engine, they will give different names. Okay, but the reason why they give different names, the reason is unknown, because we're not in that company, so we don't know why there are different names. But however, that is the result. Okay, there are different names. Okay, so next one, we can click the details. Okay, right here, the details right here. Okay, so like this this executable file, which is 684 kilobytes. Okay, if we apply different hash function, for example, MD5 function, that its hash value is FFA9FC blah blah blah. If we apply different hash function SHA-1, SHA-256, vhash, authentic hash, invoke. There are a lot of different hashes at least. Okay, so they create a unique hash value for this specific malware sample. Okay, so that is it. Of course, there are a lot of different hash functions right here, and right here, okay, it says file type Win32exe, which means, as I mentioned before, it can be executed on 32-bit Windows operating system, and this is it's an exe file. Okay, and further, there's a magic, right? It's a PE32, which means it's a P file. It is compiled into a 32-bit executable file for Microsoft Windows, and it has GUI. It has an interface. Okay, and they run on Intel 36, 32-bit CPU. Okay, of course there are some information, okay, by some made by some tools, okay, so on and so forth, like this. Okay, history. Okay, this as I mentioned before, PE file, there is a timestamp in the PE file, right? It specifies when this file has been compiled by compiler, right? So here's the create time, which is 2018, okay, June 1st, something like that. The first submission, which means VirusTotal, this website, okay, they accept a lot of, you can upload a malicious file to this website. So the very first time someone submit this file to VirusTotal is 2018, June 1st, okay, and date time like this. The last time submitted, the last time and the 6th, okay. So basically, when you upload this file, when some volunteer, okay, they upload this file, okay, there's a lot of different names. myfile.exe, 15528.exe. Basically, those names are meaningless because you can simply change it, right? So name itself, usually they are meaningless. Okay. The most important thing is the PE file that you upload. Okay, is the features you extracted from the PE files. Is the monitors you created for the for the sandbox, so they can monitor the dynamic behavior of this malicious software. Okay, so here, as you can see, signature information, signature verification means this file, this uploaded malicious file, does not have any signature, because this file is created by maybe some hackers. So it does not include any public keys, any signatures for you to verify. So that is okay. Okay, let's stop right here. Let's come back after 10 minutes. Okay, we'll continue how to extract information from the PE files.